Welcome to another session of linear programming. So far, we have discussed the meaning, application, and formulation of linear programming problem. We will now discuss how the linear programming problem is solved. Before we begin, let's recall the optimal solution. The maximum and the minimum value of an objective function is the optimal solution. But the question is how to solve a linear programming problem. Well, there are different ways to solve the problem. The problem having two variables can be solved graphically, while the problems having three decision variables can be solved with the help of simplex method. Like you can see in this case, we have two decision variables, that is x and y. So in this case, we can apply graphic method to solve the problem. While in another example, we have three decision variables, that is x, y, and z. And in this case, we will use the simplex method to solve the problem. It does not mean that when we have two variables, we can't use simplex method. We can use simplex method and graphic method when we have two variables, but when we have more than two variables, that is three x, y, and z variables are there, so this kind of problem cannot be solved with the help of graphic method. So we have to apply simplex method in such case. But for now, we will be discussing the problem based on graphic method, that is having two decision variables. To solve a linear equality, we will use a coordinate plane. We know that there are four quadrants in a coordinate plane, as we also know this that the value of x and y are greater than equals to 0, that is non-negativity constraint, which means the value of x and y should not be less than 0. This shows that they lie in quadrant 1. That's why to solve the problem graphically, we need only first quadrant. But in some cases, we get negative value also. In those problems, we will extend the area to quadrant 1, which I will explain you in the upcoming sessions. Now, before proceeding toward the solution of some practical questions through graphic methods, let's discuss some basic concepts of graphic method. Now, whenever we have to solve the linear programming problem graphically, we must keep in mind the few things. As we have already discussed that there are four quadrants and we only want the first quadrant in order to solve our question. So, this point where the two lines meet, that is the point of origin. And this horizontal line is known as x-axis and vertical line is known as y-axis. Or if it is given in question that there are two decision variables x1 and x2, then we take these two lines as x1 for this x-axis and x2 for this y-axis. Another thing is that sometimes it is given in the question that either the equation has greater than or equals to sign or the equation has less than and equals to sign. Now what does this sign represents? Whenever it is given less than sign, it means that the area of feasible solution is toward the origin. And whenever it is given the more than sign, this shows that the area of feasible solution is away from the origin. Sometimes we have a negative value. It may either on x-axis or on y-axis. So in that case, whenever we got a negative value, like suppose if I got a value minus 1 x2, right? And here I got a value of 1. So in that case, I will join these 2 points. But as we have already discussed that the feasible solution always lies in this quadrant, that is quadrant 1. So what we have to do, we have to extend this line in quadrant 1. And if it is given less than sign in this equation, it means it is toward the origin. In the same way, the area is on this side of the first quadrant. But if it is given that there is more than and equals to sign, so in that case the area lies on this side. In the same way, if we look at the first quadrant, then it is away the origin. Another thing is that sometime it is given in the question that we have only one variable, like we have x1 is equals to 8. In this equation, x2 is not given. So it means that x2 is by default is 0. And in this case, x1 is equals to 8. So my coordinates are 8 and 0, right? And if it is given that x2 is equals to 5, so in this case, it is implied that x1 is 0 and x2 is 5. So my coordinates are 0 and 5. We always write coordinate in the form of x1 and x2, right? So let's discuss first this point 8 and 0. Suppose 8 lies here and this is my x1 axis and we have 0 value of x2. It means we will not take any point on this side of the axis. So what we will do, we will make a parallel line from this point, that is 8, which is on x1 series, and this line is parallel to x2 series. But in this case, when x2 is equals to 5, means we have a point on this side. Let's suppose this is point 1, 2, 3, 4 and 5. So it means that point 5 lies here, but we don't have any point on x1 axis. So this shows that we make a straight line from point 5 which is parallel to the x1 axis, right? So now next step is that we have to see what is the sign here. If it is less than sign here and less than sign here, means less than is toward the origin on the both lines. So this shows that this portion is my feasible solution and there are 4 points of intersection. So we will take these points in order to find my objective. So these are some of the basic fundamentals you must be aware of before solving the problem.